The polar function f of theta equals r equals 2 minus 3 sine theta is graphed in the polar coordinate system on the interval between 0 and 2 pi. On which of the following intervals of theta is the distance between the point with polar coordinates and the origin increasing? All right, so this is what it's asking. This is a very confusing problem, but let's try to understand what the question is asking us. If you were given a polar graph, right, and you start graphing the polar graph, and you start way out here, and as you move counterclockwise, it moves its way in, your distance is decreasing. Now, what that looks like, okay, so again, as you move counterclockwise, this curls in, you're decreasing. What this looks like on the rectangular system is you start up here and you work your way down, okay? As you move towards the x-axis, you're decreasing. What that also means is if you were to draw this out and keep drawing this out, this too is you working towards the x-axis. So you could be in negative land, you could be going this way in negative land working towards this, and that's you also decreasing. So if your graph in the rectangular system is moving towards the x-axis, your point is decreasing. That's not what we want here. We want increasing. So what that could look like is maybe you have a polar graph and maybe you start at 0, 0, and as you move clockwise, it kind of gets larger like that. What that looks like is, again, you start at 0, 0, and you're moving away from the x-axis, okay? So that is an example of increasing. So we need to find out where we're moving away from the x-axis. Okay, so it could look like that, or it could look like that. Okay, so we're going to run to our calculator. We're going to graph this guy out. Okay, and we are going to find out where our curve is moving away from the x-axis. Here we go. All right, you ready? We are going to graph 2 minus 3 was it cos? Sine. Ooh, that was a close one. Sine and an x. Because we're graphing this on the rectangular system. So I'm going to change my window. Actually, I'm going to go to Zoom and do Zoom Trig and then change my window. All right, so as we can see, it bottoms out at -1. It looks like it goes up beyond whatever this number is. So I'm going to go and say, let's move this from -2 to, I don't know, 6 should probably do the job. Also, I care about stuff happening between 0 and 2 pi. So let's change that to 0 and 2 pi and hit graph again. Now, what I said is we care about where things are moving away from the x-axis. Interval number 1 is going to start from here and end here because at this small, tiny curve, we are moving away from the x-axis. So I need to see what that is. So that is a 0. I'm going to hit second calc and go to 0, which is the second one. I don't know why it took me forever to look for that. So let's scroll over. Let's scroll over, hit enter, and it begins moving away from, it begins increasing, I guess I should say, at 0.72, blah, 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 blah. And it's going to stop increasing right here at the minimum. So let's do minimum. Boom. Let's move to the left. Hit enter. Move to the right. Hit enter. And we get 1.57, which is half a pi. So it looks like magic happens from 1/4 of a pi, that 0.7 to 1.57. So that's our one thing, 0.7 to 1.5. Okay, I'm not going to have that memorized. You'll see it when we get back there. Now it starts increasing again from here to here. So I need to find that 0. So I'm going to repeat the process. Second calc 2. Okay, find that 0 right there. Enter, enter. So 2.4 whatever, okay, is where I start increasing again, and it stops increasing at that maximum. So second calc maximum. Let's move to the left. Enter. Move to the right. Enter, enter. 4.7. So we add like 0.7 to 1.5, 2 point, I don't remember, to 4.7. Let's go back and answer that. All right, so I hope your memory is pretty good, but that's the guy we got. Okay, so again, the picture that this looked like is from 0.7 whatever to 1.5 whatever. It looked like that, and then it came back up and went way up here at 2.4 to 4.712. So C is going to be our guy. Very tricky, very challenging problem, but again, all the problems that I make are taken kind of from the test with changes. Okay, so I hope this helps.